Okay, in this video we're going to take a look at how to deal with volume calculations and volume conversions. Okay? It's very similar to area, but fundamentally will be much bigger changes than you're used to seeing. Now, they typically will ask you to deal with the volume of some fairly common object, a cylinder, a box, or a cube, something of that nature. So you don't need to memorize a bunch of geometrical formulas here, but this is one you'll need to know. Cylinder and cube, definitely know those. So the volume of a cylinder is pi r squared times the height. Okay, pi times the radius squared times the height. Now they're going to give us some measurements to work with. It says the height is 5 centimeters, so I'm going to label that in here, 5 centimeters. Okay, and this is the diameter is 6 centimeters. Well, don't forget, diameter is 6 centimeters. The diameter means all the way across that circle. And I'm not looking for that, I'm looking for the radius. The radius of that circle is going to be 3 centimeters. Okay, now, will it always be if they give you the diameter? No, just read carefully and make sure you know what those measurements are. Look over this diagram before you jump into the calculations. Now, this is the radius, this is the height. This is a fairly easy calculation to start with if you get that stuff labeled correctly. So the volume is going to be pi times the radius squared, which is 3 centimeters squared, times 5 centimeters. Now check out what's happening here. Because of this squared, we're taking centimeters times itself. Centimeters times centimeters times centimeters. That is going to give us centimeters cubed. Okay? Pi is just a unitless number that goes in there, and we're going to use 3.14. Now, if you have a pi button on your calculator, it will not round it to 3.14. It'll do the entire pi, the never-ending decimal. And when you do that, on a big value like this, you're going to end up with a slightly different answer. Don't worry about that. Okay, if your answer is slightly different than mine, and it's just from using the pi button or the 3.14, it's not a big deal. Okay, I'm looking at how you do this, not the exact button that you used on the calculator. Okay, I'm just going to put in 3.14 for all practical purposes right now. So if I type this into my calculator, volume is going to be 3.14 times 3 times 3 times 5. Okay. And when I put that all together, I get a value of 141.3. And that's centimeters times centimeters times centimeters, which is cubic centimeters. Okay? So I have 141.3. Now once I get to that point, look, this is the volume part's done. I don't really have to pay attention to this anymore. All the rest of this is converting between different volume units, and we're going to see a very big change here. A couple of them are metric, one of them is standard, so we're going to have to set this up to our advantage, all right? So like in the previous video, we kind of got to pick and choose. Same is true here. So I'm going to look at this and go, all right, centimeters to millimeters. I can do that. Okay, I got a Z chart I can use. I have page 4 in my booklet that has milli and centi on there. I just got to remember how to read it properly, but I have this information. So if I take 141.3, and that is cubic centimeters, and I'm trying to turn it into cubic millimeters, cubic centimeters is going to go down here. Now, think about centimeters to millimeters. 1 centimeter is 10 millimeters, but we have cubic units. And we have cubic units, that means this is a volume calculation. I have to cube the conversion factors, both the top and the bottom. Well, 1 cubed is still 1. That doesn't change anything. But 10 cubed is 10 times 10 times 10. That's 1,000. So really, I have 141.3 times 1,000. And when I do that, that becomes a very big number. All right? I get 141,300. Now, when you look at this number and this number, was it just moving the decimal? Yeah. But we didn't move it just one spot because of the 10 to 1 ratio here. We moved it 3 spots. 10 times 10 times 10 because we have 3 of those measurements involved in volume. So I'm not saying you can't move decimal points, but you got to figure out how many places to move them. And sometimes that's more effort than just setting it up and letting the units get you there. Okay? So 141.3 cubic centimeters is 141,300 cubic millimeters. Big change. Look how much this changes in one little simple conversion, but it's because it's volume. Now, next in line, we're going to try and turn this into cubic meters. Okay? Pick this one or this one. It doesn't really matter which one you choose. Okay? And I look at this and I kind of go, all right, I'm going to stick right back here. I like that's kind of a smaller number. I'm going to use it instead of the big amount of cubic millimeters. They'll all get you to the same spot. So I'm going to take 141.3 cubic centimeters, again, as my starting value. And I'm going to turn it to cubic meters. Cubic centimeters goes on the bottom. All the mechanics are the same. And now I have to ask myself centimeters and meters. What's my conversion? 100 centimeters equals 1 meter. Here I'm going to be dividing. Be careful. I have to cube this and cube this. When I do that, the bottom becomes 100 times 100 times 100. That is 1,000,000. Okay, so this is going to change a lot. This is 141.3 divided by 1,000,000, and that's going to move that decimal a whole bunch and end up with a really tiny value. I get 0.000141.3. Now that's cubic meters. And look at how much that changed. Okay, did I just move the decimal from here to here? Yes, I did. However, I've got to be careful that I know how far I'm moving it. Okay, it's not the same as linear units. Okay. And my last one here, I'm going to try to get this into cubic inches. Now, cubic inches and cubic centimeters are going to be a lot closer than, say, the cubic meters. Okay, the units are going to be in at least a similar ballpark. So I am going to use this one again. I'm going to take 141.3 cubic centimeters, turn it to cubic inches. Cubic centimeters goes on the bottom. And then I have to look on my page 4, if I don't have this memorized, and that tells me 1 inch equals 2.54, but I have to cube these because these are cubic units. Now think about what this means. I'm going to take this number and I'm going to divide it by 2.54, I'm going to divide it by 2.54 again, and divide it by 2.54 again. Or I'm going to figure out what 2.54 cubed is, and then I'm going to divide these one time. It's kind of up to you. Okay, it'll all get you to the same spot. And this gives me kind of a regular sized number. This is 8.62. Okay, and 8.62 represents cubic inches. Okay, and the last thing I really want to mention here is look at the spread. Look how much different these values are. If you're dealing with cubic units, you should expect massive changes, not just moving the decimal one spot. Okay, it's always big changes jumping from unit to unit. Okay, in fact, the closest ones are these two, and that's because centimeters and inches are closest in their measurements. Okay, and that's dealing with volume. Expect to see a problem like this show up on quizzes, midterm, final. It's always there. It's generally going to see, can you do a little bit of volume calculations, and then can you take your result and correctly convert it to all these different units.